Hello everyone, today's lesson is multiplying, dividing, and simplifying radicals. Number 1, multiply radical expressions. Consider the expression square root 9 times square root 16. There's two ways to handle the problem. The first way is find the roots first. So if you have square root of 9 times square root 16, find the roots means square root 9 is 3 times square root of 16 is 4, and the answer will be 12. And that is the first way. Second way is multiply the radicands first. So square root 9 times square root 16, and you're going to multiply them together. So square root of 9 times 16. And 9 times 16 equal to square root of 144, and square root 144 equals 12. So there's two ways of doing it. Now, personally, I like the first way, breaking down square root of 9 equal to 3 and breaking down square root of 16 getting to 4. It's much easier to get to 144 and have to redo the breaking down. But that's just personal preference. Either way is correct, and it's up to you. Going on to the next thing, product rule for radicals. If both a to the nth power and b to the nth power are real numbers, so notice the n is going to be the same. Because they are the same, then you can put it underneath the square root, and the n, which is the index number, is going to be the same, can be pulled out, and then that's just a times b. Based on that rule, example 1, find the product and simplify. Assume that all variables represent positive values. So personally, I like to do it a way. Now, how do you decide which one is number 1, which one is number 2? Well, in this case, I think for you guys to do it, is number 2 will be easier just because you don't recognize all the patterns yet. For me, I can say, oh, if I multiply square root 3 times 27, that's going to give me square root 81, 9. That's multiply inside of the roots first, 27 times 3. But the number gets a little bit bigger. So that's one way you can do it. Or the other way is multiply, taking out the root. But because the roots is not available here, you don't know what is the root of 3 and what's the relationship between root 27. It is easier to multiply. Once you get a little bit better at it, you can see root 27 is 3 of them. So there are technically 4 3s. It takes a pair to come out, so that's why you have 3 and 3 equal to 9. All those, I eventually don't have to write it, just so you know. So it's up to you how you want to do it. So going on to letter B, you guys try it. The answer for letter B is 8. I can do 2 times 32 is 64 and 8. Now, just in case you guys need to see the breakdown, 64 using prime number, 2, 32, using prime number, 2 again, and that's 16. Divide by 2 again, 8, divide by 2, 4, and 2, 2. Now, if you notice that all of them are prime number, don't have to worry about doing it again. But if you do, you will left with 1. So you get 1 pair, 2 pair, 3 pair, and that 2 times 3. Please try letter C. Now keeping in mind the index number is 3. You must still multiply the same thing. 3, I will do 4 times 2 equals cube root of 8. Now you want to take the a and break it down. 2, 4, 2, 2. I have a triplet of 2. That's your answer. Next example. Letter D. You have cube root of 3x times 4x. Don't forget, because their radicand is exactly the same, you can do that. If it's not the same, you cannot do it. So that's going to be cube root of 12x to the second. Now, because that has nothing to do with 3 of the same thing times itself, what we're going to do is we are going to conclude answer for example number 2, letter D. Next one, fourth rule again, because the index number is the same, and you can have 5 times 7x squared. Now there's nothing they have in common, which is totally okay, and then you just have to combine for quadratic root 35x to the second, and you're done. And next one, you have to do the same thing. Please do it. Pause the video, please do it. For example 1, letter F, multiply the numbers inside of the root. So 5 times y is 5y, 2 times x is 2x, and just put square root over it. Please try example 1, letter G and letter H. Letter G, if you have both root index is the same, you can multiply the underneath the radicands. So there will be x times x, that give you x squared. X square root of x squared is x. That's your answer. And then letter H is just going to be square root of 11 times x, because you can just multiply them. And there's nothing to break down. The answer is going to be square root of 11x. For the next rule, raising an nth root to the n power. Raising the nth root to the nth power. And because they are the same thing, the answer just cancel each other out. The n and the nth root cancel each other out. That's just a. If you try the problem, take a look. You have n right here, 3 power. This is the index number. They are exactly the same. Your answer is just 4. If you have the index number from here's 5 and that's 5, so the answer should be whatever. Please finish the next two little underline and check your answer. The answer for the next two blanks is 19 and 3x squared. Literally, the exponent and the index number, if it's the same, they just cancel each other. So, the second objective, divide radical expressions. Now we are going to divide. So, the first way is to find the roots first. So, if you have a square root of 100 over square root of 25, then you can do square root 100 is 10, square root 25 is 5, and when you reduce it, you get 2. Then the next one is divide the radicand first. So if you have square root of 100 over square root 25, now you can actually put them under the same root, 100 over 25, and that's just 4. But therefore, we have not done anything with the root yet. I can have a 2. So you can have either way, whatever you think is best at the situation. Like last section I show you, and I ended up doing the second way most of the time. So it's really up to you. You can use either way. Quotient of rules for radicals. If both nth radical of A and nth radical B are real numbers, then n to the A over n to the B could be the same thing as n to the nth degree of A over B. To letter A, you can do a couple different ways. They want you to simplify. Assume that variables represent positive values. So now what you can do is you can say you have split this off, square root 7 over square root 36, and that's gonna be square root 7 over 6. Second one, this one I will just reduce it first because then I can see 3 goes into 108. So I'm gonna put it over together, divide by 3, and then cancel. And if I cancel that, that's going to be square root 36, and that's 6. Compared to both problems, first one I split into top and bottom right here, and then because I know square root 36 right away, I can just break it out. This one I put it underneath one root because it will make it smaller, and I know the 3 can be canceled out. So then I know when you cancel, that's square root 36, and square root 36 is 6. So it depends on the situation. Sometimes I use the rules a little bit differently. Provided if I can cancel the denominator. On to example letter C. You have a cube root of 9 over a cube root of x to the third power. And then x to the third power, they are exactly the same. So you know that can come out of the root. So that's just x, and that's just cube root of 9. Please try example 2, letter D, E, and F. Example number 2, D, I broke it down into 2 different radical, one on top, one on the bottom, because I recognize 81 to the fourth root of 81. It's really, you can break down 81 4 3s, and then so therefore I can take it out of the fourth root and give me the 3. So then that letter D. E, I notice if I can cancel the root 5 because they both on top and bottom have the same index, and because they have the same index, I can cancel them, and if I cancel them, I will not have a denominator left, and I just left with cube root of 3 as E. Letter F, I did the same thing with the cancellation because I know I can get rid of the 4 on the denominator, and I have a cube root of 8. And cube root of 8, which is I recognize is really 2 to the third power, and 2 to the third power is also cancelled out with the index number, so therefore it's 2. Real quick hand, that's also right here, cube root of 2 to the third power, and we know that can cancel each other out. Let's also give you a 2, just so you guys can see the difference, how you recognize them. Objective 3 is use the product rule to simplify radical expressions, simplify nth roots. Procedure, simplify the nth root 1, write the radicand as a product of the greatest possible perfect nth power and a number, or an expression that has no perfect nth through power in the factors. I will go through the problems with you because it sounds very confusing. 2. Use the product rule. NAB equals A n through of A n through B, where it's perfect, where A is a perfect nth power. 3. Find the nth through of the perfect nth power radicands. So there's a lot of different things in there. There's square root, there's underneath the square root. If there's anything that's perfect, you have to take it out, and making sure that roots are as simplified as possible. So let's take a look at what they mean by that. Example 3 says simplify. So we have some examples. A, so we know A is 18. And we're going to say 2, 9, 3, 3. And what they are saying is I actually have a perfect, I can circle it. In this case, a pair of 3. Anything that has any kind of perfect needs to come out of square root. So in this case, the answer is just going to be 3. It came out root 2. And root 2 is whatever's left over, you keep them inside. And we've done that before. You guys try letter B. Letter B, I hope everybody have no problem breaking down, and I hope everybody have no problem circling the 5, a pair of 5. A pair of 5 comes outside right here. That's a pair of 5. But whatever's left over, 2 and 3, is going to stay inside. So therefore, 2 times 3 doesn't have pair, stays inside, and when you multiply, that's 6. And a pair that is, you have a pair that's perfect, and that comes outside. So therefore, letter B is going to be 5 root 6. For letter C, we are going to take 72 and divide by 2, and then that's going to give us 36, and divide by 2, and that is going to be 18. Divide by 2, that's 9, and then 3 and 3. See, there's a pair of 2, there's a pair of 3. Because of square root, we are only going to circle 2 per group. Then don't forget there's also a 5 outside, and you're going to multiply the 2 that came outside times the 3 that came outside, and the square root 2 that does not have a pair stay inside, and your answer is going to be 30. 2 times 5 times 2 times 3 is 30 square root 2, and that will be your answer for letter C. Please try letter D yourself. So D, 3 root of 80, square root of 80. Break down the square root of 80, and then so that's right here. Break down the square root of 80. Then the 2 comes out right here. The 2 comes out right here, and the 5 is left over, it's right here. So the answer is 3 times 2 times 2, that's 12, root 5. For letter E, you have a cube root. If it's a cube root, you need to circle a group of 3. So let's break down the 40 and see where we are at. 2, 20, and then you have 2 again. You got 10, you got 2 again, you got 5, all right? So you have a cube root. Circle the 2 because a pair, a triplet of 2. So that 2 comes outside. We also have a y to the 5th. So if y to the 5th, I told you guys, think about that's 5 muffins, and I need 3 muffins to make a box. So therefore, 1 box is made. So just 1 comes out. Or if you want to, you can say y, 5 of them. And then I want a group of 3. 1 comes out, and then 2 left inside. I usually like to break it down into 2 parts. I have a cube root of 5 left, and then I have y square. And that is how I put my pieces together. Now, sometimes it's just not, it just need to leave a little space to get everything all taken care of. And there's the answer is going to be 2y cube root 5y to the 2nd. Please give it letter F a try. For letter F, I did it 2 ways. 2 things. I took care of the number as a problem. Then I did the n as not a problem. So if I break down both of them, you can see that I have 108 broken down 2, 2, 3 all the way. A group of 3 comes out. I put it right here. Then I do and then I just start writing 3 index number, and then I have 2 times 2. So I take care of the number first, but I make the line a little bit longer. Then I say n to the 11th power. So I have 11 muffins, 3 per box. I make 3 boxes. I have 2 muffins left. For n to the 3rd power, that's when I do it. And then I put n to the 2nd because I have 2 left right here. Then I simplify and combine them. So I have 3n to the 3rd power cube root for n to the 2nd power because 2 times 2 give you 4. Let's do letter G together. Is now 162. I'm going to break it down. 162, 2, 81, 3, 27, 3, 9, 3, 3. Now it's a 4 through, so I need 4. And the way I'm going to write it out is going to be 4m to the third power, which is found before. I'm going to bring it down, times. I have a 3 came out, and I'm going to make a 4 through something. But I know I have a 2 left. Notice I only took care of the numbers first. Then I'm going to take a look at the m to the 7th power. So m to the 7th power, I will have 7 divided by a box of 4. That give me 1 box for 3. So 3 is left inside. But I can make 1 box of muffin. So it's m to the first power, and then m right here, I have 3 left. Okay, this number right here goes right here. That's 1. This number right here goes to this 3, and this is the index number. Now I'm gonna combine them all together. So number gets multiplied together, so that's gonna be 12. And I have m, 3, and 1, give me 4. I have a 4th power in the little check mark, which is radical sign, 2m to the 3rd power. Please try h. Letter H is I broke down the 80, took the 2 out right here, and then I have the exponents, 2 boxes outside, 1 box in, 1 left over inside, and therefore a combined 2 times 3 is going to be 6, x to the 7th power, x to the 2nd power, x to the 9th power. Cube root 5x. That is your answer for letter H. And that concludes the notes for today. Thank you so much for watching.